Okay, so on this video, I will show you how to find the higher order derivatives of some algebraic functions. For instance, if we let y equals f of x, then dy dx, df dx, y prime, f prime of x denote the first derivative. And if we want to get the second derivative, we differentiate the first derivative. So we have the second derivative of y in terms of x, the second derivative of f in terms of x, and this is y double prime, and this is f double prime of x. And differentiating the second derivative will give us the third derivative, and that is denoted by this expressions. And then finally, as we go along, the nth order derivative can be denoted by the nth derivative of y in terms of x, d to the nf over dx to the n. Then this is read as nth derivative of y in terms of x, and also this is read as nth derivative of f in terms of x. And to execute this higher order derivative, we can still use this basic and fundamental differentiation formulas from the derivative of constant, derivative of power, derivative of sum, derivative of product m, derivative of quotient. And from my previous video, I showed you some special formulas in finding the derivative of this function, ax plus b times cx plus d, then ax plus b all over cx plus d, then the derivative of c all over x raised to n, and the derivative of the quantity ax plus b raised to m times cx plus d raised to n. Okay, so let's have some example. If we wish to find all the derivatives of y equals x raised to 5, and then we might use the power formula. So for the first derivative, we have y prime. So you can bring this down and then copy x, and then you subtract 1 from 5. So we have 5x to the 4. And then for the second derivative, you just multiply 4 and 5. So that's 20x to the third power. And then for the third derivative, you just multiply 3 and 20. So that will give you 60x, and then you subtract 1 from 3. And that will give you 60x squared. And for the fourth derivative, you multiply 2 and 60, that's 120x, and then you subtract 1 from 2. So you'll have 120x. And then finally, for the fifth derivative, that's the derivative of 120x, and that will give you 120. And for the sixth derivative, and since this is already a constant, and then the derivative of constant is equal to 0. And you will notice that on the seventh derivative, okay, the eighth derivative, the ninth derivative, and even on the higher order derivative, okay, and that will always equal to 0. So which means whenever you were given a function y equals x raised to n, where n is an element of positive integers, then the derivative of this x raised to n will start to become 0 at n plus 1 order. Okay? So meaning the n plus 1 derivative of y in terms of x is equal to 0 for y equals x raised to n element of positive integer. For instance, if we have y equals x to the 12 and we wish to find the 14th derivative of y in terms of x, okay, since this is larger than n, okay, this is the order and this is n. Since 14 is larger than 12, and then we might say that the 14th derivative of y in terms of x is 0. Okay. Now, the question is, can we get the higher order derivative without passing through the lower order? Okay. Say, for instance, can we get the fifth order derivative without passing through or without looking for the first, the second, the third, and the fourth derivatives? Okay. So let's check this out. If y equals x raised to n, and again, where n element of positive integers, okay? And then we have y prime equals, you bring this down, okay? You copy x, and then you subtract 1 from n. So that is nx raised to n minus 1. Then the second derivative, you copy n, you bring this down, okay? And then copy x, and then you subtract 1 from n minus 1, and that will give you n minus 2, okay? Next, for the third derivative, you copy n minus 1, and then bring this down, copy x, and then you subtract 1 from n minus 2, and that will give you n minus 3. And then as we move along, the fourth derivative is equal to n times n minus 1 times n minus 2 times n minus 3 x raised to n minus 4. Then following the pattern, you have the fifth derivative, n times n minus 1 times n minus 2 times n minus 3 times n minus 4 x raised to n minus 5. And moving on, we have the sixth derivative, the seventh derivative until we reach the kth derivative where k is the order. If we let k be the order, the higher order derivative, okay, one more. If we let k be the higher order derivative, and then the kth derivative of y in terms of x can now be written as n times n minus 1, n minus 2, n minus 3, running until n minus k minus 1, okay? X raised to n minus k, okay? And we can still simplify this n times n minus 1 times n minus 2 running until n minus k minus 1 by applying the permutation formula, npk. And that is equal to n factorial all over n minus k factorial, where n factorial can be written as n times n minus 1 times n minus 2 times n minus 3 running until n minus k minus 1, and I will stop at n minus k factorial because of this n minus k factorial here. Okay, and then we can now cancel this out. Okay, and that leads us to n times n minus 1 times n minus 2 times n minus 3 running until n minus k minus 1, and that is equal to this expression. Okay, so finally, the kth derivative of y, okay, in terms of x can be written as npk times x raised to n minus k. So this is the generalized formula in finding the higher order derivative without looking for the first, the second, the third, and the lower derivatives. Okay, let's have some example. Okay, if we want to verify the fourth derivative of y in terms of x given y equals x to the 5, and then here we notice that n is equal to 5, okay, and k is equal to 4. Okay, so we have, following this formula, the fourth derivative is equal to 5p4 times x raised to 5 minus 4. And 5p4 is equal to 5 factorial over 5 minus 4 factorial, and 5 minus 4 is equal to 1. So that's 5 factorial all over 5 minus 4 factorial times x. And simplifying this, you have 120x. Okay. Then, now, the question is, what if there is a numerical coefficient in front of x to the n? In this case, so we have y equals c times x raised to n. Then, following this formula, we will just put c, okay, c in front of npk. So we have the kth derivative of y in terms of x given y equals c times x raised to n is c times npk times x raised to n minus k, where n element of positive integer and c element of real number. For instance, if we have y equals 1/2 x raised to 7, we wish to find the fifth derivative of y in terms of x. Okay, so here we know that n equals 7 and k is equal to 5, and that c equals 1/2. And then using this formula, okay, so we have c, okay, so we have c, that's 1/2, okay, 7p5 times x raised to 7 minus 5, okay. So simplifying, that will become 1/2 times 7 factorial all over 7 minus 5 factorial times x. 7 minus 5 is equal to 2. And then simplifying further, we have 1/2, then 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 factorial. And I'll stop here because 7 minus 5 is equal to 2. And then you can now cancel this out. And then multiplying them all, that will give you 1,260x squared. And that is the fifth derivative of y in terms of x, okay, for y equals 1/2 x raised to 7. Okay, one more. Say we have y equals 1 over x to the 4th power. Okay, so since the expression x to the 4 can be found on the denominator, then we might use our special formula for the derivative of c all over u raised to n, and that is equal to negative c times n all over u raised to n plus 1 times du. Okay, So we have y prime. You just multiply 4 and 1. So 4 times 1, that's 4 all over x raised to 5. And then you multiply it by negative 1. So dy dx is equal to negative 4 all over x to the 5th power. And then if we want to get the second derivative, so you just differentiate this. Okay? So we look for the derivative of dy dx in terms of x, and we differentiate negative 4 over x to the 5. And that will give you the second derivative of y in terms of x. So following this formula, so we have 5 times negative 4, that's negative 20 all over x, then 5 plus 1 is 6, and then from the formula, we need to multiply it by negative 1 times negative 1, and that will give you positive 20 all over x raised to 6. Okay. And then if if y equals c over x raised to n, then the kth derivative of y in terms of x can be written of this form. Okay. So you have negative 1 to the kth power times c times n plus 1 times n plus 3 running until n plus k minus 1 all over x raised to n plus k. For instance, if we have y equals 1 over x raised to the 4th power, and we wish to look for the 4th derivative. Okay, so here, n is equal to 4, k is equal to 4, and c is equal to 1. Okay, so you have, following this formula, the 4th derivative of y in terms of x is negative 1 to the 4th power times 4. Okay, this is your n, then n plus 1, n plus 2, and you will stop at n plus k minus 1. So you will stop at n, that's 4, plus k, that's 4, minus 1. So this is 4 plus 3, and that will become 7. So you will stop at 7. So that's 4 times 5 times 6 times 7, then all over x raised to n plus k, that's 4 plus 4. Okay, and then simplifying, you will now have 840 all over x raised to 8. Negative 1 to the 4th power is positive 1. So then 4 times 5 times 6 times 7 is 840. And then all over x raised to the 8th power. Now, we can still expand this formula for y equals c all over the quantity ax plus b raised to n. Okay, say we have y is equal to c all over the quantity ax plus b raised to n, where n element of positive integer and abc element of real number. So if we want to get the first derivative, so we have n times c, okay, then times the derivative of ax plus b, that's a, and then you multiply it by negative 1 all over ax plus b raised to n plus 1. And then looking for the second derivative, so you copy c n times a, that's c times n, then you bring this on the numerator, so that's n plus 1, then a times a. Okay, so this a square came from this a, and then another a came from the derivative of ax plus b. Okay, and then you multiply it by negative 1, that's why the second derivative is positive. Okay, then doing the same process for the third derivative, so that's c times n plus 1, and then you bring this on the numerator, so you'll have n plus 2, and then times a squared, and then you multiply it again by the derivative of ax plus b, and that is a. So that's a cubed, okay? And then you multiply it by negative 1. So you'll have negative c times n plus 1 times n plus 2 times a cubed all over ax plus b raised to n plus 2 plus 1, that will become n plus 3. And then as we move along, so the fourth derivative is equal to c times n plus 1 times n plus 2 times n plus 3, a to the 4th power all over ax plus b raised to n plus 3 plus 1, and that will become n plus 4. Now, when you look at the patterns, okay, this is the fifth derivative, and when you look at the patterns, you will notice that we have for the power of its, for the sign of its derivative, then first derivative, that's negative, second derivative, it's positive, third derivative, it's negative, fourth derivative, it's positive, fifth derivative, it's negative, which means on the odd order of derivative, then its derivative will become negative. And on the positive order of derivative, okay, so the derivative is positive. Okay, so that means we have negative 1 to the k times c times a. This is a to the 5, fifth derivative, a to the 4, fourth derivative, a cubed, third derivative, a square, second derivative. That's why we have here a to the k. And then you will notice that n times n plus 1 times n plus 2 times n plus 3. The question now is, at what term are we going to stop? You look at here. So this is 4. This is k. That's 5. This is 3. This is 4. This is your k. So that's k 3, 3. 3 is equal to 4 minus 1. So this is your k minus 1. Okay. So you will stop at n plus k minus 1. So all over ax plus b raised to n plus 5, fifth derivative, 4, fourth derivative, plus 3, third derivative, plus 2, second derivative, plus 1, first derivative. So that's n plus k. Okay. So for instance, if we have negative 1 all over 2x minus 3 to the 7th power, and if we want to look for the fourth derivative of y in terms of x, so here we notice that n is equal to 7, yeah, it's n, and then k is equal to 4, and that your c is equal to negative 1. And you take note that the derivative of 2x minus 3, that is a, is equal to 2. So we have the fourth derivative of y in terms of x is negative 1 to the fourth power times c, that's negative 1, times a, that's 2 to the fourth power, times 7, times 8, times 9, times 10. We will stop at 7 plus k, that's 4 minus 1. So this is 3, so that's 7 plus 3. Okay, and that is equal to 10. Okay, all over 2x minus 3 to the 11th power. So that's 7, 7 plus 4. That's n plus k. Okay, then simplifying, we have negative 80,640 all over 2x minus 3 to the 11th power. Okay, next. Say we want to look for the derivative or the all derivatives of y equals 3x plus 2 to the 4th power. For the first derivative by chain rule, so that's 4 times 3x plus 2 to the 3rd power times derivative of 3x plus 2, and that is 3. Okay, and then simplifying, 4 times 3 is 12. And then for the second derivative, so that's 3 times 12, that's 36, okay? And then 3x plus 2 to the 2nd power times derivative of this again, that's 3. And that will give you 108, okay? Times 3x plus 2, okay? Yeah. And then for the third derivative, we have 108 times, you bring this down, okay? So that's 2. Then copy 3x plus 2, and then you subtract 1 from 2. This is 1 times derivative of 3x plus 2, which is 3. And then multiplying this, 108 times 2 times 3 will give you 648, then times the quantity 3x plus 2. And then the fourth derivative will give you 648 times the derivative of 3x plus 2, which is 3. And then finally, that will give you 1 times 944, which means on the fifth derivative will give you 0. Okay. And then as you can notice, we can generalize this of this form. So if we have y equals c times the quantity ax plus b raised to n, where n element of positive integers and abc element of real number, then we have this special formula. So that's the kth derivative of y in terms of x is equal to c times a raised to k, where a, this is the derivative of ax plus b, okay, times npk, okay, following the the permutation formula, where npk is n factorial over n minus k factorial, times the quantity ax plus b raised to n minus k. Okay, say we have, if we want to look for the third derivative, so we shall verify this result by applying this formula. So the third derivative of y equals the quantity 3x plus 2 to the 4. So we have here n is equal to 4. Okay, that's 4. And then k is equal to 3 because we are looking for the third derivative. Okay, and then we have a is equal to 3. Okay, and then c is equal to 1. Okay, since there is no coefficient here. And then the third derivative of y, or y triple prime, is equal to 3 raised to the third power times 4p3 times the quantity 3x plus 2 to raised to 4 minus 3. And then simplifying, we have 3 cubed is 27, and then 4p3 is 24. Okay, and then times 3x plus 2 raised to 4 minus 3 is 1. Okay, so that's 27 times 4 will give us 648 times 3x plus 2. And we get the same answer here. Okay, next, say we have y equals the quantity 4 minus 1 half x raised to the 7th power. And we wish to look for the fifth derivative of y in terms of x. So we have n is equal to 7 and k is equal to 5. So we have here a is equal to negative 1 half. And then following this formula, so we shall now have negative 1 half to the fifth power times 7p5 times the quantity 4 minus 1 half x raised to 7 minus 5. And simplifying, negative 1 over 2 to the fifth power is negative 1 over 32. Then 7p5 is 2,520 times 4 minus 1 half x raised to the second power. And then simplifying further, you will have negative 315 all over 4 times the quantity 4 minus 1 half x raised to the second power. Okay. Next, say if we want to look for the second derivative of y in terms of x, if y equals the quantity 2x minus 3 times 3x plus 1 half. And then we might use this special formula. The derivative of the quantity ax plus b times cx plus d is equal to 2acx plus bc plus ad. So here, we note that a is equal to 2, b is equal to negative 3, okay? Yeah, and c is equal to 3, and d equals 1 half. Following this formula, so we have 2 times a times c, okay? That's negative 3, okay? 2 times a is 2, c is 3, sorry, c is 3, not negative 3. So 3, okay, x plus b, b is negative 3, times c, which is 3, and then plus a, which is 2 times 1 half. Okay, and then we have this. Okay, 2 times 2 times 3x plus negative 3 times 3 plus 2 times 1 half. And then we shall have this is equal to 12x. 2 times 2 times 3 is 12. Then negative 3 times 3 is negative 9. 2 times 1 half is 1. Negative 9 plus 1 is negative 8. And then the second derivative of y in terms of x will give you 12. That's the derivative of 12x minus 8. Okay, one more. Let me see. Okay, we wish to find the fourth derivative of y in terms of x if y equals 3 halves x raised to 7 plus x raised to 5 minus 2x cubed plus 7x plus 10. By applying the sum, the derivative of sum and derivative of power, we shall have the first derivative is 7 times 3, that's 21, over 2x to the 7 minus 1, that is 6. And then you bring this down, 5x to the fourth power minus 3 times 2, that's 6x squared, then plus 7. The derivative of 10 is 0. And the next, the second derivative, 6 times 21 over 2 is 63, yeah, x, then subtract 1 from 6, that's 5. Then 4 times 5 is 20. X, 4 minus 1 is 3. And then negative 6x squared, the derivative of which is negative 12x. And then the derivative of 7 is 0. Okay. And then the third derivative, so you have 5 times 63 is 315. Yeah. X to the fourth power, that's 5 minus 1. Then 3 times 20 is 60x squared. And then derivative of negative 12x is negative 12. Okay, and then finally, the fourth derivative will give us 4 times 315 is, I think it's 1,260, yeah. And then x, 4 minus 1 is 3, then 60 times 2, that's 120x. And then the derivative of negative 12 is 0. And finally, the fourth derivative of y, okay, is equal to, okay, so we can differentiate this or we can use our special formula, okay? So that's the 3 halves times the fourth derivative of x to, the fourth derivative of x to the 7 in terms of x plus the fourth derivative of x to the 5 in terms of x minus 2 times the fourth derivative of x cubed in terms of x plus 7 times the fourth derivative of x in terms of x plus the fourth derivative of 10. And we know that the fourth derivative of 10, okay, is equal to 0. Okay, since this is 1, and since the 4 is larger than 1, then the fourth derivative of x is also equal to 0. Okay, and this is 3. And since the 4 is greater than 3, then the fourth derivative of x cubed is also equal to 0. Okay, and then we might use our special formula to find the derivative of x, the fourth derivative of x to the 5 and the fourth derivative of x to the 7. And we shall have 3 halves times 7, this is your n, this is your k. 7p4 times x raised to 7 minus 4. And then here, this is your n and this is your k. So that's 5p4 times x raised to 5 minus 4, that's 1. And then this is 0, 0, 0, okay? And then finally, we have 3 halves times 7p4 is 840, okay? X cubed, that's 7 minus 4, plus 5p4 is 120, and then x, 5 minus 4 is 1. And then finally, the fourth derivative of y in terms of x is equal to 1,260 x cubed plus 120x. By the way, I'd like to apologize for this notation. This is the fourth derivative of y. Sorry for this one. Okay. This is the fourth derivative of y in terms of x because this is the derivative of the third derivative. Okay. Next, say if f of x equals x plus 2 all over 2x minus 3, and we wish to find the second derivative. Since we have here function of the form ax plus b all over cx plus d, and then we might use this special formula. Okay, that's ad minus bc all over cx plus d squared. So here, we know that a is equal to 1, okay, b is 2, c is 2, okay, that's 2, and then d is negative 3. So we shall have, okay, so that's AD, that's 1 times negative 3, that's negative 3, minus BC, that's 2 times 2, which is 4. So that's negative 3 minus 4 will give you negative 7 all over 2x minus 3 to the second power. Now, if we want to get the second derivative of f of x, then that will become, okay, so that's negative 7, 2x minus 3 to the negative 2. Okay, and then differentiating, so you have negative 7 times negative 2, then you copy 2x minus 3, and then you subtract 1 from negative 2 times the derivative of 2x minus 3. So you have negative 7 times negative 2 times the quantity 2x minus 3 to the negative 3, then times 2. Okay, and then we shall have 7, negative 7 times negative 2 is positive 14, times 2 is 28 all over 2x minus 3 to the third power. Okay, let me see. Okay, one more. If we want to get the second derivative of y in terms of x, if y equals 3x squared minus 2 to the fourth power, then differentiating this by applying the chain rule. So again, by power formula, you bring this down. So 4, then you copy 3x squared minus 2 to the third power, then you subtract 1 from here. That's why it's 3. And then times the derivative of 3x squared minus 2. And then we shall have 4 times the quantity 3x squared minus 2 to the third power. And then the derivative of 3x squared minus 2 is 6x. And then simplifying, you have 24x times the quantity 3x squared minus 2 to the third power. So differentiating this again, we get the second derivative. Okay, so that's 20. Okay, so we will now apply the derivative of product. Okay, so this is your u, okay, and this will be your v. So v equals 3x squared minus 2 to the third power. So we know that the derivative of u is dx, and then it's 1, sorry, it's 1. One more, it's u equals x and v equals 3x squared minus 2 to the third power. And then du is equal to 1 and dv equals 3 times 3x squared minus 2. 3 minus 1 is 2 times derivative of this, that is 6x. Okay, and then finally you have 18x times, yeah, 3x squared minus 2 to the second power. And we shall have 24 times u, that's x, x times 3 times 3x squared minus 2 square, then 6x. So that is your dv. And then plus, this is your v, then derivative of u. Okay? And then simplifying, we shall have 24 by common monomial factor. We can factor out 3x squared minus 2 to the second power. And then 3x times 6x will become 18x squared, yeah, plus, and then there will be 3x squared minus 1 left on the second term. And then simplifying further, you will have 24 times times 3x squared minus 2 to the second power, and then you collect similar term here, and that will give you 21x squared minus 2. Okay, and that's it for now.